All right, I think it's time to get started. So, hello everyone. Thanks for coming to this session. Let's see where I can control this from. There we go. All right, so we're going to talk about getting into backend development. A large focus of this talk is for people who maybe haven't written much PHP code before, that sort of thing, or JavaScript code before, and are interested in kind of what the thought process is like for doing that sort of thing. So first, an introduction. My name is Ashraf. I have all the Acquia Drupal certifications. That's what the first bullet is. I run Debug Academy out of the DC area. We teach Drupal and React, Drupal 7 and Drupal 8 and React. Our most popular course is a 3-month course, which is part-time, starting in June. The 10th semester will start this June. Classes are twice a week, 3 hours each, and a unique aspect of our classes, we actually contribute to Drupal every semester. So we get a new design, we build it, and we contribute it. We also have a 1-day React class. So if you're interested in any of that, come grab a brochure, take my card, etc. But I know that's not what you're here for. So we'll get to the topic. Right. So what does it mean when we say you want to code something? Let me just see if I can make this bigger. Okay, so when we say we want to code something, really what you're saying is you want to translate it into code. Translate whatever the client's asking for into code. And somewhere that I see a lot of people get stuck on is they feel that if they can explain what needs to be done to a person, then they should be able to find the equivalent code to what they're saying. But the difference between coding languages and human language is that coding languages have much more limited vocabulary. On top of that, programming languages, or computers that read programming languages, they cannot read between the lines. There's no body language, there's no tone. So if you tell me what you want, you tell me your business requirements for a task. For example, I have a client the other day who's asking me to charge taxes automatically, basically. When they say that, I can infer a lot. You obviously want to charge taxes for invoices. I might have some questions. Do you want to charge taxes when nothing is sold and it's only labor? Do you always want to charge taxes, etc.? But computers are basically, they're dumb machines. My math teacher used to always say, calculators are dumb. It's you who has to type everything exactly correctly, or else it will give you something that's completely irrelevant. So as a programmer, what you're doing is you're really translating the requirements from a natural human language into this limited vocabulary that computers understand. And that might make you think of something like Google Translate. So are we basically taking in words and translating them into another language the same way Google Translate does? Not really. The way that Google Translate does it is basically one-to-one. It maps words to the same word in a different language. And that's usually good enough for people. I walked around Spain with my Google Translate app and translated everything around me, and a lot of it didn't make sense grammatically, but I could figure it out. Computers cannot figure anything out. It has to be literal, exactly correct. Computers don't read between the lines, they read the lines themselves. And that's why it's hard to automate. That's why that's why programmers are in demand. Because it's really hard to automate translating a natural language into code. And this line here sums it up for me. Programmers comprehensively translate tasks using a limited vocabulary into a language that is unnatural to humans. And that's kind of why programming is hard, because you can't really drop any part of that sentence. If you take out the word comprehensively, it doesn't work. So you have to translate the whole thing using a very limited language, and a language that doesn't come naturally to most people. So let's take a glance at a couple of the languages. Some people will say HTML and CSS don't count, but they are programming languages nonetheless. So the languages have limited vocabularies and capabilities. If you look at a couple of them, for HTML, you might say the vocabulary of HTML is basically the elements on the page. A link, a division, a section, a table. And web browsers are the ones that understand HTML. HTML, on the other hand, nobody talks to HTML. CSS, somewhat similar. Its vocabulary is styling related, positioning related. Web browsers understand it. What does CSS understand? It might react to you putting the mouse over an element. So in that way, there's something of a two-way conversation. And this talk does get into, actual practical programming advice at the end as well. So PHP is the primary language used in Drupal. Its vocabulary is too much to list here, but some things it does is deals with data. It can read data, store, create, modify. It's understood by the web server. So PHP is not understood by your browser. It's only understood by the server that PHP runs on. So PHP will be read by the server, and then something else will be given to the browser, typically HTML. And PHP also understands the web server, as in it can be triggered by the web server. The web server can give information to a PHP file. It can call on a PHP file, that sort of thing. But your browser itself is not going to send something directly to PHP. The PHP example here, it's more dynamic than what you saw with the CSS. We have if user is logged in, return this message, else return a different message. So PHP is a more dynamic language. Its vocabulary spans more than something like HTML and CSS. And JavaScript. Similar to PHP in many of its capabilities. It can read variable, read data, write data, etc. You can create functions, loops, dynamically generate content on a page. But JavaScript talks to the browser. PHP does not talk to the browser. The browser can also talk back to JavaScript. The browser can say, a user put their mouse over this area, and JavaScript can understand that. So if you're, one of the things to consider with programming languages is, what is this language for? What is it good at? With PHP, the fact that it only talks to the server in some ways makes it a better candidate for more secure conversations, accessing data from the database. JavaScript, the fact that it can understand information from the web browser makes it good for interactive pages where you, move your mouse over a section of the page and some other section of the page reacts, that sort of thing. So every language kind of has things it's good at and things that fall within its vocabulary. One exercise that many recommend is when you're getting into, not starting out in programming, really like as part of your computer science degree, to create your own programming language. We're going to walk through an exercise with an imaginary, in real life programming language to kind of get you thinking about how to translate requirements into code. The main idea we're trying to get across here is you have to work within the limitations of the language, within the vocabulary of the language, and you can't leave anything out from the requirements. So in this language, we're saying this made-up IRL language has a load person function, has the ability to load a person, has the ability to rotate a joint, say a word, and locate something. And you can also do other standard programming things like store values in variables. So this language is understood by any human using mind control, and it reacts to essentially Twitter follows and newsletter subscriptions. I know there's marketing scattered throughout here. You can ignore that if you'd like. So this is a very simple language, but we're going to use it to walk through the thought process. So let's say we were told by our client, I want to control someone with this language and I want to make them sit down. Sounds simple. People will often get stuck at this point. If they're working with PHP or whatever they might be working with, they'll come and say, well, how do you make someone sit down? I Googled sitting down. You know, I don't see a code sample for sitting down, that sort of thing. You have to think about the limitations of the language, what functions the language has. And this language has the ability, has rotate joint, so it's like joints on your body. So you're going to have to use that to make someone sit down. So you first, you think about it, you kind of, prototyping is faster than research sometimes. So first we load the person. And remember, this language responds to Twitter follows and newsletter signups. So when somebody follows you on Twitter, we just load that person. And then we use our rotate joint function. Left knee 90 degrees, slow. All right, so I'm going to have to do some of this. So I bend my left knee 90 degrees. After that, we're rotating the right knee 90 degrees. It seems like it's making sense when we're writing the code, but when you actually implement it, that didn't work. So I'm sitting here, and now I'm gonna rotate my hip. You have to work within the confines of the language, but computers are dumb. They're really literal. So at this point, you would switch back to research mode. Okay, I tried using the vocabulary. I got close. I ended up in a sitting position, but I was on the floor. So what needs to change? In this case, it's essentially that I need to do all of those at the same time. I can't do one and then the other. So the idea is you'd research, you'd find out how to do them at the same time, and you'd try again. You load the person, you rotate the left knee. Before finishing, or at the same time, you rotate the right knee, and you rotate the hip. So in this case, you do all three at the same time, and you have a sitting person. So you can celebrate. It works on my machine. We're going to do one more example, but this is kind of the thought process with programming. You have to take yourself out of what do I want it to do and think of how do I tell it to do this within the confines of the language? What can this language do? And how do I add those together to accomplish my goal? And sometimes you need to get clever for that to work. And that comes with experience. So just a refresher, we have the load person. I think I skipped a slide on my machine. Okay. So here's another task. This one says, everyone in the room stand up. How do we accomplish that? You might think, well, we're just going to rotate the joints again. This time we'll do the opposite of what we did before. Maybe rotate them all, the knees, the hip, in the other direction. But when I'm saying that, there's certain things I'm saying that we haven't put into words that the computer understands. Like when I say, everyone will do X. The fact that I said everyone, that's a problem. that's not a statement that this language understands at this point. Remember, this language understands Twitter follows or newsletter follows. So for you to say everyone, you have to make everyone take that action. Basically, nothing is implied in programming. You can't assume you have everyone in your code. And that's where you sometimes have to get clever to make the language's vocabulary work for what you're trying to do. So I bolded the ones we're going to use here. So we have load person, and that loads essentially the most recent Twitter follower. Say word, so you have the ability to make someone say a word. Reminder that it's understood by humans and it understands Twitter followers. So let's try to implement that within the confines of this language. You can sometimes get clever because the language simply doesn't have abilities past what we listed. So you can throw in a manual step. The teacher or presenter has to follow the account on Twitter so that you can trigger the first step of this. And then you can utilize the say word. So you can make the teacher say something. So you can have the teacher, like I go ahead and I follow the account, and then this code runs. And I basically say, follow Debug Academy on Twitter. I'm cringing with the marketing stuff here, but the idea is I say that to the room. And at that point, some other language is going to have some effect, where it's almost like we're using an API. We're talking to other software. So now natural human language is going to have an effect. Between us, I say that message. And then for everyone who follows, the idea is the room follows, and then we can continue our code. The next person who follows on Twitter, you expect it to be each person in the room one by one. So the next person would be the first person in the room who follows the account. And you load that account, and you do what we did in reverse, the sitting, but we're just flipping the degrees from positive to negative. So they're sitting, left and right knee rotate negative 90 degrees, and the hip rotates 90 degrees, and that gets you to standing. So in this case, we're working around the limitations of the language by using another language, natural language, in between. And that's where you kind of have to sometimes get clever to work, to make a language do exactly what you're trying to accomplish. But the code I've written so far, really, it makes the teacher say this message, and then it makes the first student who followed stand up. So what about the rest of the class? We can write that code again, make the next person stand up. And write that code again, make the next person stand up. Write that code again. And, slow and steady wins the race, right? This is fine. It might be fine if you're the only developer, but when it comes to maintaining the project or someone else coming behind you to update your work, writing this kind of code quickly gets out of hand. So it's fine when it's just you, but when the next developer comes, it's not a good look. I'm gonna let that one play again because I really like that joke. Yep, pretty bad. And that in that example, we're just talking about, okay, you sit down, now we all stand up. It's not the most complicated task. So let's say the task actually said, make the latest follower go to Chipotle. So how would you accomplish something like that? That one's more complicated. You have to really get thinking out of the box to make that one happen. We're not going to do that whole example, but you could start with something like, okay, let's load the person who followed on Twitter. let's find Chipotle, because this language does have a locator function. Let's find the person. So we're going to compare their location. The distance between Chipotle and the person, if it's greater than 0, if distance is greater than 0, then we're going to try to make the person walk. You rotate the knees, the ankles, etc. 45 degrees for the knee, 25 for the ankle, and the idea is you're supposed to make a person walk with this stuff. That's really complicated. It's incomplete. What if they're walking in the wrong direction? What if it's not a 2D world and it's more complicated than that? Continuing in this fashion, we're not finished and it's getting complicated. At some point, you're just going to be over it. You're not going to want to write this whole code using this language. You're kind of reaching the practical limitations of the language's native vocabulary. Bear with me 1 second. So in that case, where let's say that is the right language, but that's just a ton of code to write, that's where frameworks come in. Okay. So a framework essentially is pre-written code used as a starting point for your project, where you might get this whole big starting point and then you write additional code playing by the rules that this framework has established. Frameworks typically have useful functions that you can use and a predefined project structure that you should follow, and it has pre-written code to handle common scenarios, and it often addresses much of what you would write yourself. So for example, if you wanted to make somebody walk, instead of using the joint functions directly, if you use the framework, chances are this framework would have a function called walk. And you could just say person.walk, and you don't have to think about the implementation details. You don't have to think about the very low-level code that's making that happen. There are many frameworks out there. Here are some of them that are relevant in the Drupal world. For CSS, Sass isn't quite a framework. Sass is like a language on top of CSS that adds additional functionality to CSS to make writing CSS easier. Bootstrap is a framework often written with Sass, and it simplifies writing CSS. So with CSS, you use styling. You might say something like, this is this wide, that tall. I want it to float to the left of the page. I want something else to float to the right of the page. I want it to have a gap of this many pixels. But if you're using Bootstrap, you would say something more like, Bootstrap has standards. It says the page, by default, is assumed to be 12 equal columns wide. And you could say, well, this item that I want to place on the page, I want it to, using Bootstrap code, you would say, I want it to span 2 columns. That's how wide I want it to be. I don't need to think about how many pixels that is. I just want it to be 2 out of 12 columns wide, and I want it to be positioned in the first position. And then for the other one, you could say, I want it to be 5 columns wide, and I want it positioned in the third position. Bootstrap has default spacing between columns. It has the ability to automatically resize your page. So these are it's a lot of code you would write with CSS that you don't have to write because you're using the appropriate framework. JavaScript has jQuery and React and many more. jQuery is in Drupal core, and it contains a lot of pre-written JavaScript code, a lot of functions that make accomplishing goals with JavaScript much easier. React is another library that essentially allows you to divide your page into little blocks or components. You can place them anywhere on the page, and if you interact with one and your interaction is relevant to another one, React will update the other one automatically. Like if you have an add to cart button, you press add one to the cart, and you have a checkout in parentheses one item at the top of the page, React will update that number for you. If you think about doing that in plain JavaScript, it gets complicated fast. You target an element, you might listen for the add to cart button, and when you hear that interaction from the browser, you have to find the checkout button, find the current number, replace it with one higher. But React just does that all for you. All that you say is, I want to print this. And they're both using the same number, and from then on, it'll update both anytime one is updated. And PHP, we have Symfony, the framework, provides a lot of pre-written PHP code, and Drupal is written using the Symfony framework. So Drupal actually follows the rules laid out by Symfony. And any custom Drupal modules we write also follow Symfony's rules. So why did they build Drupal 8 on Symfony? I saw the issue that kind of sparked this conversation, of we should just use Symfony instead of keep continuing to write everything ourselves. And the conversation was about the routing system. Routing is complicated. Loading the right page and the right piece of content, the right block in the right context, while using a system like Drupal, writing that code is very difficult to do. And people were working on that. And someone realized, Symfony does exactly what we're doing. Why are we writing it all from scratch? And that's kind of what brought Symfony to Drupal. So they looked at it, they said we share a lot of the same values, very well-written code, high standards, and Symfony just has modular pieces of code we could put together to essentially rebuild Drupal. And that's what they did. So now that Drupal is written using Symfony, first of all, it saved a lot of time for the people who were writing Drupal 8. Second, whenever Symfony is updated, Drupal gets those updates. So you get to benefit from Symfony's security updates, for example, and newer versions of it and maintenance without you touching that part of the code at all. But it has implications for Drupal's architecture, because when you use a framework, you follow the rules of the framework. So that's why Drupal has YAML files. In its modules and themes, you'll see files that end in .yml. That wasn't the case in Drupal 7, but that's something from Symfony. It's one reason that Drupal switched to object-oriented programming, and that it follows a specific naming convention or namespace convention. It's more than a convention, rules. It gets that from Symfony, and it's Symfony's way of finding your code. And it's why you have to name files with certain naming conventions. So when we're talking about frameworks, we're really, people are often saying, well, I don't want to learn a framework because it's harder. If you're writing very simple applications, it's probably true. Learning a framework is more work. But if you're writing a complicated application or a large application, think Walk to Chipotle with that app we were writing, that would take forever, writing it with the native language itself. But if you put the framework on top of it and you have a walk function and a turn right function, turn left, etc., I don't want to think about how do I have to move my joints to turn left. So a framework would come with all of that sort of thing. I'm moving this in and out because a few of the slides I went out of order. So as far as the thought process of understanding code goes, or really translating customer requirements into code. What we've been talking about is the main idea. You really have to focus on the confines of the language's vocabulary, on what can trigger something in this language. In PHP, you shouldn't be thinking about when the user moves their mouse over this button, I want my PHP code to do this, because PHP doesn't listen to the browser. So when you learn to code, you want to kind of develop an intuition for what can this language do, what types of functionality should I expect this language to have, and then you get good at researching and seeing when I want to accomplish something, can I find things that I can use together to accomplish that. Now, we wrote some code that I said is good for one person, but when another developer comes behind you or you try to update it later, you're going to have a problem. So there's some rules, best practices for writing code, for writing better code. And you'll see a lot of mid-level developers, even senior developers, that don't follow all of these principles, but the best architects follow these principles. And the nice thing about them is they're things that you can follow at any stage of your career. It might not be natural immediately, but you can look at them and look at your code and think, how do I adjust my code to kind of try to follow these principles more? So I didn't come up with all of these, but I didn't come up with any of the acronyms. KISS, that one's keep it simple, stupid. If it's possible to make your code simple, you should do it. If you have a cool way to do it, or you think you're being clever even though there's an easier way to do it, generally shy away from being clever. Sometimes people like to write code that only they understand, even if they won't admit it. They like to write code and show it to someone, and that person's like, wow, how did you do that? But really, that makes it hard to maintain. So do your best to write the simplest code you can. With our classroom example, with you want the whole classroom to stand up, we went with the teacher saying everybody follow on Twitter. It's not the simplest, but if you want to bypass that and say, well, maybe somebody won't listen, or you just want to say, I don't want to do it that way, I want to actually find every person. Like, I want to use the locator to find every person in the room. Maybe I'll locate this chair and that chair and that chair and that chair. If there's no real technical benefit to doing that, it's just personal preference. Always pick the one that makes the code simpler. Try, don't repeat yourself. This one is important, and we violated it repeatedly. We had our code that said, everyone in the room stand up, and we wrote it, and then we wrote it again, and we wrote it again. So that's a violation of the DRY principle. In that case, you would want to create a function that handles standing up. So you say stand up equals these 4 lines of code, and when each person signs up for Twitter, you just call stand up. That one's really important. That one's really important because let's say we have scattered stand up throughout our system, and then our doctor tells us, well, your legs shouldn't be at, your knee shouldn't be at 180 degrees. It's bad for you. Make it 178 degrees. You're going to have to go back through every time you wrote that code in your code base, and that's hard to search for when there's so few functions, and you're going to have to update it everywhere. But if you have a stand-up function, just go to the stand-up function, update it there, and then throughout your code base, it's immediately everybody is following the doctor's advice. Single responsibility. Ensure every function does only one thing and does it well. So for the go to Chipotle function, You could maybe create a function called, go to a restaurant, and you put all of the code that we were writing inside of that function. But that would be a violation of the single responsibility rule if we were to put all of that code in there, because you shouldn't be writing the code for standing up, writing it out inside of the function for going to Chipotle. So going to Chipotle requires multiple things to be done. Basically, for each thing that you're doing, you would create a function. And if you are able to make each function do one thing, it makes your application much easier to test, because let's say the person doesn't end up at Chipotle, instead of just having this huge mess of code to look through to see where it went wrong, you have functions that each do one thing. At least one of them is not doing the one thing correctly. So instead of testing your whole application, you can test your function that does one thing and make sure it's doing that one thing correctly. So your stand-up function, you can run it through a bunch of tests. If the person's laying down, let me call stand up and see if it works. If they're sitting, let me call stand up. If they're already standing, let me call stand up. Okay, stand up passes all of these tests. I don't need to worry about it. That's not the thing that's breaking the go to Chipotle function. Same for a walk. You can call a walk. Maybe if you call a walk before they're standing, you'll find that that's your problem. You forgot to make them stand before they were walking. So making the single responsibility principle just makes it much easier to debug your application and test it. Separation of concerns. This one basically is saying to write your code. Don't combine code that doesn't need to be combined, or don't combine code that can function separately. I'll step out of our analogy for this one. React, I mentioned, is a library that lets parts of the page update automatically when another part of the page is updated. React is a front-end only library. You can't use React directly to query the database. You'll have to use another tool to query the database. So it's following the separation of concerns, and they followed it relatively strictly because they said, we don't want React to store data in a database. We don't want React to do anything except for interactions on the front end. You can then add your backend behind that so it interacts with the database. But React itself, all that it cares about is the front end. And it's completely distinct. And its code is all separate. So let's say, one reason that's useful is, let's say you're having a problem on your website, or you want to upgrade Drupal 7 to Drupal 8, and Drupal 7 was your backend for this React app. Because they're coded separately and they work independently, you don't have to change React at all. You can just take out Drupal 7, put Drupal 8. You have to update the backends, but you don't have to change React if you are following the separation of concerns. You ain't gonna need it is another popular acronym. Don't assume that a function's going to be useful. Like, let's say in the code we were writing, I mentioned a walk function. We want to say walk, or let's say the stand up. So we got the stand up working. Now, the developer might be like, oh wow, I'm getting the hang of this. Let me make a jump function, because I bet they're going to want to jump for joy when they get to Chipotle. I'm just going to create it, and eventually we'll use it. 50% of the time or more, when you do that, when you create a function because you think it'll be useful later, you either forget you created it or you just never use it. Or both. But the thing is, you don't tend to benefit from creating functions when you don't need them. There's no added value of creating it in advance. There's a risk of lost time. So you should only write code for accomplishing the current task. Another one is to make it work and then make it good. Also popularly coined avoid premature optimization. So a lot of times people will be building a site and they'll say, oh, well, this is probably going to be a bottleneck because I'm going to get so many visitors. And when they all sign up, maybe they shouldn't be stored as users in Drupal. Maybe they should be stored, in an Amazon bucket or something like that. Like, let me get that all set up properly to plan for this scale that I'm definitely going to hit. It's similar to you aren't going to need it. With that one, you might optimize a part of the site that maybe it does need optimization if you get 1 million users, but you would have needed to optimize something else first. Maybe before you get 1 million users, you realize that the registration form is a little long and it's deterring people from actually signing up. So you're only getting tens of users because you didn't optimize the registration form yet. So the idea is you should make your code work and then put it out in the wild, and you'll see where the bottlenecks are, and it might not be performance related, it might be something else. And then you kind of focus on those as they come. There are exceptions to this. If it's Netflix building the next Netflix app version, they know where their heavy traffic is. But in general, you don't want to optimize things because you feel like the optimization might be useful. Oh, right. And this one's very important. Easy to understand naming. I often see people who are starting out with programming use variable names like X and A, B, C, things like that. That makes it so hard to read your code. Your variable names should not only be relevant, they should be self-explanatory. In the PHP slide earlier, we had a variable named user is logged in. And that's very clear. If it's true, the user is logged in. If it's false, they're not. Even like login status, or if you just had a variable named login, it's not clear what that is. It's not clear if it's like, is this their session token? Is this true or false? Is this the user? So you want it to be really explicit. User is logged in, that sort of thing. There's a bunch of quotes out there. There are only 2 hard things in programming: naming things, catching, and off by 1 errors. But naming things, you wouldn't think that would be in the hard things about programming. But you'll see, like, senior developers might write a variable name, delete it 5 times until they have one that they're like, okay, this can't be misunderstood. This is very clear. And that stuff really ends up being very useful throughout the project. And it also applies to function names. Remember, functions should only do one thing and do it well. Make it really clear what they do in their name. Comments are great, but the comments don't follow the function around. Code comments. So if you create a function over here and you put a comment that says, this function does this, it's like, well, great, but you're using it on this other file, and I don't have that comment anywhere near me. You're making me go look for it if you have a comment. I don't even know that you have a comment there, so I might not even check. So you want the naming to all be self-explanatory, to the point where if the logic in your application changes and you feel like the names of the variables no longer make sense, that's a good thing. It's making you rethink what your application did before, and you might need to update your names and update the code a bit. We are nearly out of time, I think. But so in summary, when you're programming, you're translating from human language to a language the computer understands. Computers are unintelligent so far. Programming languages are all very limited compared to the languages we speak. And most critically, computers do not read between the lines, and that's something that I find people who are starting out in programming, it takes some getting used to. There is no context except what you explicitly give it. So when you translate what the customer wants, you're comprehensively describing the task using the programming language's vocabulary. Comprehensively is a very important word in that phrase. Customers will often ask for a feature and they don't comprehensively describe the feature. They'll say, with the tax thing that I mentioned, the customer said, we want to collect taxes every time that material is sold. We want taxes to be billed for it at the rate of the county. And I did that. And the customer 2 weeks later says, oh, okay, well, we don't want to charge taxes for this one company because they're tax exempt. So where's the button for me to do that for that company? And I'm like, it's code. I translated what you said literally because maybe I didn't ask enough questions, but I now need to write more code to make that possible. There's no implication. There's no obviously in code. Your computer doesn't think about the code, and that's why asking questions to the customer is important. Whenever they say always, you have to ask them, okay, always except when. You have to find what are the exceptions. And do your best to follow those write better code bullets. So I hope you enjoyed the presentation. I hope it was beneficial. Again, if you're interested in the thorough Drupal class, it's not all... I am teaching next semester, but we actually get into the code on day one, and we go through it all semester. And you leave the class with experience building custom modules, contributing to Drupal, and more. It is kind of a all-in-one class. If you have never programmed before, it's good for you. We'll give you some pre-class work. If you have a master's degree in computer engineering, it's also good for you. We have classes that regularly have people of all those backgrounds. Basically, regardless of where you come in, 2 out of the 14 weeks will be boring for you. It's just a question of, is it the first 2 weeks or the last 2 weeks, depending on whether you're a beginner or advanced on your way in. And if you already know Drupal, we have a one-day React class. These classes are all available online, Wednesday nights for 3 hours, Sunday mornings for 3 hours, or if you're in the DC area, you can attend in person on Sunday mornings, but it's online Wednesday nights for everyone. Yeah, so I guess that's the last slide. Yeah, I hope that was beneficial. I hope it wasn't too beginner. But yes.
What are the classes for these courses?
The React class, that one sold out at DrupalCon for $450, but if you take it outside, it's $400. The 3-month class, that one's $3,600, but we have payment plans up to 2 years. And people typically take that class to switch their jobs, so if the payment is a problem, just contact me and we'll talk about figuring out something that works for you. Me and one of the alumni of the class gave a talk at DrupalCon Nashville called Extending the Abstract Class of Privilege. We're very focused on making Drupal accessible to people. So I don't like when people tell me we can't take the class because we can't afford it. So in that case, we have room in the class, 1 or 2 spots a semester to be very flexible. Let's see, and actually at DrupalCon Nashville, an event with about 3,500 people, 3 of our alumni were speakers, and they each had different sessions. We weren't involved in them applying or anything. So it is, very deep developer education. The expectation is not that you get an internship after the class, it's that you get a job. And yeah, I'm happy to answer other questions. Yes?
The React course you mentioned, what's the difference between that one and some other React course, such as Udemy or...
Yeah, good question. So what's the difference between our React class, React in a Day for Drupal, and React for Udemy, that sort of thing? We teach React for Drupal, so really it is React, but we apply it to a Drupal site with decoupling your site. So we show you the Drupal side, how do you decouple, and without decoupling. So we say if you have a Drupal site that is already exists and you want to kind of spice it up and make the forms more interactive, this is how you can throw React on top of it. So that's one side of it. The other side is it's live. We make sure that you can get the code done, live in class, and it's very much up to date. I'm working with the Drupal core React, the JavaScript team, working on the React Administrator UI, and I'm making sure to teach what's going to come to Drupal. Any other questions about? It doesn't have to be about this slide. It could be about anything, but I'm open to it. And like I said, we have brochures, business cards, sports bags. You're welcome to help yourself to anything. Yes?
I have a question. Let's say for someone just getting into Drupal and the backend, what's a good, so we talked about I guess understand the limitation of a language and analyzing what things are good for, but what's a good way for someone to understand what specifically is in the domain of the backend for them to work with? So it's you may be doing PHP or whatever, but what are you interacting with in PHP? What's a good way to really
to understand the limitations of PHP?
Well, not understand the limitations of PHP, but what are the specific things we're interacting on the back end of Drupal? I imagine there's just a lot of stuff.
Yeah, Drupal has a lot of ways of doing different things. There's some things you can do through the front end, like you can create a page without writing any code. You can create your content architecture. You usually do create it without writing any code. You can create forms without writing any code, but you can also create forms with PHP and everything else. You can create it with PHP as well. It's hard to give a short answer. If there was a short answer to this is how to know what to do, how to do this in Drupal and that in Drupal, I probably wouldn't have made the class. Drupal is nuanced, and it's got kind of a steeper learning curve, which is good and bad. It's good because, first of all, it's architected very well, and that's what makes it kind of not so. And when I talk about architected very well, it's very flexible. You can modify anything in Drupal without touching Drupal core's code, and that's a pretty big deal. The way that you could override anything. If Drupal's sending mail using one service, you can create a different mail service and use a different mail tool, and just make all of Drupal core use your mail tool without touching Drupal core's code. So it's very powerful and flexible. But to accomplish that, each piece of it is accomplished in a different way, basically. I know it's not a satisfying answer, but
it's a big question.
yeah. I mean, with the theming, they have twig files, another language, and we use Sass on top of CSS. In the back end, you have your custom module files, but you have different object-oriented classes for a form than you do for configuration or content. Yeah, it's a good question. It's just not it's its own 8-hour answer. Any other questions? All right. I think that's 55 minutes or so. So I honestly didn't get a schedule, so I'm not sure the exact end time, but if anyone else knows. Okay. Thank you. Thank you.